Hello, Geometry. Welcome to Lesson 4, Angle Relationships, Part 1. These are our main ideas for this lesson. Again, after our lesson, you should be able to define and sketch the following terms, okay? So let's start with the types of angles. An acute angle is just an angle whose measure is less than 90 degrees. So it's between 0 and 90 degrees is an acute angle. A right angle is an angle whose measure is exactly 90. And we always think of this as like a square. Squares have all right angles in the corner. So our little hint there is that a right angle always has that little marking of a box in the corner. An obtuse angle is a measure of 91 to 180 degrees. So anywhere between that range is an obtuse angle. So it's bigger than a right angle. And lastly, a straight angle, I should say 179. Let's be a little more accurate there. Because a straight angle has a measure of 180, and we know that 180 would just be like a line. So what are the measures of the following angles, and classify each of them as acute, right, obtuse, or straight? So let's start with this first one here, angle LKN. So let's trace that out. So remember, start with the first letter, L to K to N. So I need that whole angle right there. So if we start from over here, we know this is 290, and if we keep going, 100, 110, 120, 130, 140, and then it goes right there, so 145. And always put the degree mark. So where does that fall in our range up here? Well, it falls up right there. We know that is obtuse. All right, let's do L. Excuse me, I'm all over the place. Angle JKL. Angle JKL. There's that angle there. So this one's kind of odd. Now, just use our protractor, just count. We know that each big tick mark here is 10. So there's 10, 20, 30, 40, 50, and tack on another 5, so 55. And since we see that it's 55 degrees, we know that that is acute. Then our last one here, angle JKN. K to K, and then ends over here. Well, lucky us, we know that's a right angle because it goes straight to 90. So 90, which gives us the right angle. So congruent angles are just like congruent segments. They mean they have the same measure. And we mark congruent angles with this little half moon arcing mark. So if we have angles that are congruent, we'd say the measure of angle J is equal to the measure of angle K. So the congruent statement would be that angle J is congruent, remember that's this sign here, to angle K. To use the diagram below, which angle is congruent to angle WEM? Let's trace it out. Start with W, find B, go to M. I know I kind of smudged it with my pen here, but we know that that had one arcing mark. So now we need to find an angle in here that has one arcing mark. So I see it's right here. So I'm going to trace it out. There's my arcing mark, and then come over here. Now this label it by 3 points we hit. So I'm going to start with YEM. So angle YEM. And remember, E is my vertex. Says angle 1 is congruent to angle 2, solve for x. Justify each step. So here's that word justify again, so we're going to write a little proof. So let's start with what we know. We know that angle 1 is congruent to angle 2 because it's given to us. So that's what we're going to start with. So angle 1 is congruent to angle 2, and that's because it's given. Now our next step would be if the measure of angle 1 is equal to the measure of angle 2. And that's just definition of congruent angles. Now we already know what measure 1 equals. It's 6x plus 2. And we know that the measure of angle 2 is 9x minus 10. So we're just going to substitute those in for our angles. So we said the measure of angle 1 is 6x plus 2 is equal to now the measure of angle 2, 9x minus 10. And there we just use substitution. Now remember, when we solve for a variable, we want to get all of our variables to one side. So let's move this 9x over here. So by doing that, we're subtracting negative 3x plus 2 equals negative 10. And that was subtraction. Now we have to move our 2 over to get the x by itself, so subtract 2 from both sides. We get negative 3x equals negative 12. And again, that was subtraction. And lastly, to get x by itself, we divide by negative 3. So x equals 4, and that was division. So there you go. There's our proof. Again, we're just explaining our reasoning for what we did. It's all just kind of algebra, but we just have to explain each step. Find the measure of angle KLM if the measure of angle KLB is 26, and the measure of angle BLN is 60. So let's just kind of mark up our diagram here. So it says the measure of angle KLB is 26. So let's find that one. Here's KLB, and that's 26 degrees. And then it's telling us the measure of angle BLM is 60. And we want to know what this big angle KLM is. Luckily for us, we see that the big angle is just made up of our 2 smaller ones. So all we have to do, let's first write this out. So our big angle KLM is just our 2 smaller ones added together. So let's just plug in what we know. We know that KLB is 26 and BLM is 60. So adding those together, we get 86 degrees. Kind of the same situation over here on the right. It says find the measure of KLU. So that's actually a smaller angle. That's pretty off. Let's try that again. If we know that the measure of ULM is 20, so this small guy is 20 here. And then they're telling us the big picture, the whole big angle right there is 110. So remember, this time we know the whole and we know one piece. So we know the whole is 110, and we know the other chunk is 20. So to find this missing piece right here, we just subtract them. So 110 minus 20 is 90 degrees. So if that looks familiar, it should. That's just the angle addition postulate. We had the segment addition postulate, but now it's the angle. So remember, just your big angle is made up of adding the 2 smaller angles together. So our last problem here, it says if measure of angle ABC is 175, what are the measure of angle ABD and the measure of angle CBD? Justify each step. So again, we are writing a proof, but that's okay. We've gotten pretty good at that by now. So let's start off with what we know. We know that the measure of angle ABC is made up of our 2 angles there. So let's write that. So the measure of angle ABC equals the measure of these 2 smaller ones added together. So let's write that up. Measure of angle ABD plus the measure of angle DBC. And that is angle addition postulate. Running out of So now, what do we know? We know that the measurement angle ABC is 175, so 175 equals, and then we know that these two angles are equal to these two things, so we're going to write that in. The measure angle ABD is 6x minus 5, plus the measure of DBC is 4x plus 10. Remember, that was just substitution. We're just substituting in what we know. Now again, we just want to clean this up, so that's just simplifying. Let's get our x terms together here. So 6x plus 4x is 10x. And then negative 5 plus 10 is just 5. That's simplifying. Now I want to get x by itself, so I have to subtract 5 from both sides. So we're left with 170 equals 10x. That was subtraction. And lastly, divide by 10. 170 divided by 10 is 17 equals x. And that is division. All right, so we didn't even ask the question yet, though. So what are the measure of angle ABD and CBD? So we have to plug in. Let's see if I can put that on here. I can't, so I'll have to tell you guys what it is. Okay, so the measure of an angle ABB is equal to 6x minus 5. I'll plug in our x, so 6 times 17 minus 5. We get 97. Same thing for the measure of angle CBD is equal to 4x plus 10. 4 times 17 plus 10, we get 78. And just to check to see if we did it right, 97 plus 78, 175, which is what our big angle equals. So we checked out okay. Okay, thanks for watching, guys. Again, let me know if you have any questions.